And I want to welcome on stage the first speaker of this block, Dr. Youngjae Maeng, who is my friend. We worked together at the CCDCOE. We met at Locked Shields. We were playing and hacking together operational technology devices. And he will be talking about the cloud-based live fire exercise called Apex. Welcome him on stage with a round of applause.
Good afternoon. I'm Youngjae Maeng from South Korea. It's an honor to be here to share my experience about cyber exercise. So maybe you are curious about this background image. It's a chessboard, right? I think what I did on my experience was similar to this image make on cyber range, make on GAMENET. So this could be a case study for those who are interested in building a new live fire cyber defense exercise. So live fire cyber defense exercise technically means there should be lots of network systems and services for blue teams to defend, for red teams to attack. Then who will build this system is a green team. So from the very beginning, green team is very busy on developing, deploying, operating, and monitoring everything so that this live fire goes on well. So this calendar is last year. South Korea had a new live fire cyber defense exercise, so-called Apex. And I became a green team, red team leader of this exercise in the middle of March. It was right after the partner one of Luxus. I just got to South Korea and became a green team leader of the exercise. And I'm heard that this exercise, Apex exercise, should be happening in the middle of September. It sounds like I have 6 months, but actually it's not, because there were 2 test runs were planned. The first test run was on July. That means 4 months. But what I'm planning was to build an infrastructure and a platform for the exercise. That means the core of the exercise. Then becomes a lot shorter. I will explain it later. So as soon as I become a green team leader, I was checking what resource I have at the moment. No infra and no on-premise server was ready. And so that's why I had to use cloud. We used cloud for running live fire cyber defense exercise. That was the only option for us, for me. And I heard the budget, how much budget we have, and heard that it was so limited. We cannot run a large fire exercise with that budget, but still we can run a small size live fire. And small team. At the very beginning, it was only me who was starting to make a plan and design this architecture of cyber defense exercise. And not enough time, I already mentioned this. So I'm going to build the live fire cyber defense exercise. It will be a cross-team exercise. So what I've heard is that we don't want to make competition. We want an exercise that different teams cooperate each other, sharing their information to find a vulnerability, to make some patch script. So we can provide them throughout the portal system. And there should be a compatibility with Luxus, because it was already planned to have some contents from Luxus, for example, web services and operation system, and then OT system, power grid. So we have to consider the compatibility with the Luxus. And the long-term sustainability. What this means is that actually South Korea had live fire exercise before, several years back, from 2016 to 2019. There was an exercise so-called cyber conflict exercise. It was a live fire, but it couldn't keep going on because it was too heavy to maintain. So it became like a lecture for me, because I was a green team, red team leader at the exercise as well. So this time, if I have a chance to make once more, then I wanted to make a very light one, thinking of very efficiency. So if you are making a CDX just for one time, maybe we can just focus on the vulnerabilities and the exploits. But this time, I just wanted to focus on the green team stuff, more likely core green team stuff, for longer sustainability. So from now on, I'm going to introduce what I did last year to make this new live fire exercise step by step. The first thing we did was we bought domain. So we bought the public domain, for example, something.net. It's used for using VPN access. It's the only service exposed to the outside. And we bought some private domains, for example, Selenoa, Nickelonia. For example, Selenoa is good guys, and Selenoa is in the opposite side. We use these domains in the GAMENET. And we have to choose some collaboration channel, collaboration platform. For example, from the beginning, different teams need to make a meeting to decide anything related to cyber exercise. And maybe we can install open source ones, but as I said, we wanted to reduce any resources. So what we chose is the SharePoint and the Teams, so that we don't need to install by using our manpower. So using this Entra ID, we can manage users' accounts and share documents related to exercise. And you can do some communication throughout this platform. And I start to think what we should build. As I said at the beginning, it was only me who was planning and designing. Later, I got 3 more in-house developers, but definitely it could be not enough for building a live fire exercise. So my focus was to minimize required manpower to develop anything. So I was thinking, like, okay, let's make a list that is necessary for CDX. So we bought domain, we chose collaboration platform, and then infra. So as I said, we didn't have on-premise server at the moment. So we were searching cloud platforms, what cloud we are going to use. We chose Azure, simply because it has a better Windows support. We wanted to make a GAMENET like this on Azure. So users will access to this GAMENET using VPN. So VPN is the only service that is exposed to the internet. And when it's time to do some exercise, it's happening in the private network. And we started to dig into Azure, because at the moment, it was my first time to use this Azure cloud. So the first thing in the Azure I did was I decided naming convention. So when you make a VMware virtual machine, from the first thing is which team is this virtual machine is in, and the next thing is a subnetwork and the service name. So starting from this, in Azure, you can simply make a virtual network. It's so-called VNet. First, you make a VNet, make a virtual machine. It's easy. You can simply done by using Web UI or Azure CLI. And if you make another one, another VNet, and make a VM there, then basically they cannot communicate to each other. how can we do it? There's a network peering. In Azure network, if you make a different VNet, there's a button to connecting each other. It's so-called peering in Azure network. So I found a way to make a connection between different networks. And subnets. So my idea was that a single blue team will have a single VNet. And in this VNet, we'll have several subnets. For example, we want to have several subnets in blue team network. We doesn't want to have just a single network in blue team network. So we made it. But the problem was that the Azure network, all of the network communication is done by Azure. It's not done by my setting. I didn't set any routing, no. What I did was just setting IP address and make a network appearing, that's all. That means Microsoft Azure Cloud is controlling all the network communication, including routing. But in our case, it's a live file anyway, so we wanted to make our own custom routing. We wanted to put our custom routing and the firewall in the blue team's network. And I found this setting. For example, if you make a virtual machine, you can make a so-called UDR, user-defined routing. But this machine is the next hop. It's kind of setting of routing. So you can set the next hop IP address like this. But this hop address we cannot use from .1, .2, .3 because it's already reserved for Microsoft Azure use network. So we chose to .4 as our gateway IP address. And we make a VM that has .4 IP address. We used OPNsense to handle this .4 IP address and route and does the firewall for every traffic that's coming in and out through this router. And for the green team purpose, we made two networks. One is CNET, simulated internet, and the other one is MGMT, management network. Why we made these two is that, for example, in CNET, we wanted to make all the communication go through this firewall we made. But this management network, for example, doesn't have a route table. That means it will use Microsoft's one. That means even if there is a router turned off, for example, some problem happened, it still can approach access to the blue team's VM. That is good for management purpose, because if you want to build this kind of setting in the on-premise server, it's kind of tricky. But by nature, this Microsoft network, they provide this kind of setting. So it was a good thing to use Microsoft's Azure. So from now on, we just got to know, okay, I think it became possible to make a private network to build a cyber defense exercise. Then the remaining thing is that how can you make a platform for the exercise? As I said, we are not, as a core green teamer, we don't want to focus on the vulnerability and exploits. We wanted to build an exercise platform that is easy for the other green teamers to deploy VMs easily. So we used this collaboration platform as a single sign-on as well, because this entry ID, we can use this authentication for every single service we make. For example, inventory, Git, this portal system, snapshot management, all the web services we made, we used this entry ID authentication. It was not enough. So we also want to some kind of authorization. So we made a single sign-on server for the additional authorization. And other things I'm going to explain in later. Yes. So this is one of the concepts we had. We wanted to minimize what needs to memorize. This is important because as a core green teamer, for example, if we make different services that has different ID and passwords, what happens? What happens is that the other green teamers will give you some emails saying that, can you initialize my password? This is kind of interrupting if there's many green teams. Core green teamers, their daily work is to build this exercise. They are using all these services every day, so they are unlikely to forget their password. But the story is different for the volunteers because they don't use our system that much. So they initially set their password and just simply forget. Then when core green teamers are busy, if we receive this kind of emails, it's kind of interrupting. So we decided to use only single password when accessing our live fire exercise environment. And the VPN profile doesn't require any password. It's just a file-based one. We use the Open VPN. So when we invite the users, then we send their account and password entry ID and this file, VPN profile. Still, he doesn't need to memorize many things, just one password. And even though we did this, sometimes these users erase the email and forget this VPN profile. So what we made is some kind of this welcome page. This is also exposed to the internet. So user access to this site using entry ID. Then once he accesses this welcome page, then he can download this VPN profile again, so that these green teamers can focus on their main task. And the next thing we did was to just simply install the Git. We set all the scripts in Git. And we used this Git as a wiki and the inventory because we wanted to have all the VMs listed in this Git. And it's needed, this Git is needed because we are going to make a deployment system. So all the scripts from Git we are going to maintain. So here's the deployment system. As we are using Azure Cloud, we can simply use Azure CLI and invoke a script to set up services and set up vulnerabilities. And what we did was that, as I said, initially we used the Git as the inventory as well, but it was not enough. So I made just a single web page, just one page based inventory that has all this information: network, VM name, role for the Ansible, and the full name that I explained already, and VM status, IP address, FQDN, OS, and so on. So all the required information for deployment should be there. And then for the deployment, we need also certificate. Remember, we bought some domains. And when we are deploying web services, we need to have a certificate. We are using free certificate services, but problem is that if you are making many queries, there's a limit. So we have to make a cache service to download these certificates. And one other service we made is that snapshot management. In Azure Cloud, it's possible to make a snapshot and restore from this snapshot. But the difference from VMware is that in VMware, you can make a snapshot memory as well. but in Azure Cloud, it makes a snapshot only the disk. So it was important that when you make a snapshot, you have to turn off the VM before you make a snapshot. And inventory, Git, certificate, snapshot, all these are connected to this deployment system. It's based on Ansible. We chose Ansible because, as I told you, we wanted to have some kind of compatibility that with LuxShield. So LuxShield is using Ansible, so we also chose to use Ansible because we wanted to reuse some codes there. It's 100% compatible, but still, many of the codes are reusable. And if you see this image, there's some icons there, the green light. It says the VM running. It was important for us that if you are deploying the same setting for all different teams, when it comes to like troubleshooting, we wanted to know whether it's a network problem or even VM is powered on or not. We wanted to check. So we made a simple Azure CLI comment to check if this VM is turned on or not. For example, at the moment, we had 8 number of blue teams and two teams for testing purpose. For example, we chose 51 for the green team purpose and the 52 for the red team purpose, red team testing purpose. So far, I've been checking the list I made, and rest of is that the portal and the available checklist remained. It was kind of like a tough decision to decide whether we are going to develop this portal or not. Maybe we can simply choose to use open source ones. For example, CTFD. We can like modify the CTFD to use as a portal system. But we found that we need more services that doesn't provide CTFD does. For example, we wanted to have credentials for the blue team systems, and it has also forensics. This one CTFD can cover, but still we wanted to have reports for the non-technical part teams. For example, there will be inject, and we wanted to score this inject, and it's not just one time used. If there's a scored one, they just want to review once again. This should be happen. This kind of function we could not find from the CTFD. And yes, the ticketing. We also implemented the ticketing inside this portal system. And the rebirth. Based on the snapshot we made, blue teams can just make us revert their snapshot based from this portal system. So there were more functions from this portal system, so we just decided to make our own portal system. It's a kind of single entry point. After getting to GAMENET, what users are facing is just portal. Then from this portal, users can visit every single service we made. And after that, maybe you need some kind of monitoring for operating this CDX. For example, if you have your on-premise server, then you might want to monitor how many percentage of CPU is used, and RAM and disk as well. But in our case, we didn't have to use this kind of service because we are using Azure service. They're doing their work well. So it's like unlimited resource for us. So we didn't have to monitor the physical server resources. The next one, I already explained, we wanted to check whether the VMware is turned on or off. And next thing is that I made for the lock shields. This is different because it also checks the network is reachable or not. For example, even there's a service, this availability checker is checking from different source IP addresses. This check also shows you the make a visualization so that when it comes to when it's time for the main execution, just before main execution, you want to make all green so that blue teams can do their work. But if the number of services are too many, it is not easy to check or make all green. So this kind of visualization will help for green teams to do some kind of fast troubleshooting. And this is what I made for the Apex. It's a visualization of availability check. I just wanted to show the first one. This one is a last year's one, first iteration of Apex. We had the power grid. It's easy to read because green means OK, red means not OK. So every blue team had the 15 number of web services and power grid as an OT system. What this system does is that it has hundreds of headless web browser. Through the proxy, it accesses to the target web service. It makes a screenshot and does some resize of the image so that after this browser make a screenshot and the resize of the image to the smaller size, and it sends it to the OCR. I use the Tesseract. Why we use it? We wanted to automate checking whether the site is defaced or not. In this way, we didn't have to invite the user simulation team. We just wanted to automate these kind of functions. And this availability checking is only showing its index page, but in the background, it is visiting all the different URLs it has, URIs. For example, if it has a login function, it tries to log in. If it has, for example, file upload function, we are checking this file upload function, and also the download, so that we wanted to check the functionality as well. For the average checking, we differentiated the IP address because we are using A-class network. We can have tons of IP address. In this way, from the blue team's SIM or SOAR network services, we want it to look like a real environment. For example, if there's this kind of traffic generation, what happens is that there will be only red team traffic. Then it is different from reality. Blue teams tries to just block everything from red team's IP address. So it is very important to hide the IP address that red teams are using. That means we need more number of IP address for normal traffic generation. That means this availability check is not just checking its port liveness, it is also checking functionality of services, and it's also traffic generation, which is very important for live fire cyber defense exercise. And this is this year's 2025's Apex availability. This year almost the same, but we had 3 different OT systems: the power grid and 5G and healthcare. So it had hundreds of headless browsers running inside of this server. And maybe you noticed that when it shows you the result, it gives you some small text. It gives you some hint whether the web page is defaced, or if the web service is not reachable, it gives you some hint about it. It has like a router issue or certificate issue. This kind of hint I gave it to blue teams for the faster response. Yeah. And importance of the availability check is the thing that it has one of the biggest scoring budget. For example, it's a live fire exercise that blue teams have services they need to keep up and running. What if blue team turns off their system? Just simply turns off, then red team cannot attack the system. If the red team's attack score is bigger than the availability score, then blue team's strategy will like, okay, we can just turn off. We don't want to be attacked, and we can like take advantage from not being attacked. So it is very important that total availability score is bigger than the red team attack score. So summing up, this availability check is not just checking functionality of the services that blue teams have, and it also have one of the biggest scoring budget. That's why it is important. And to mimic real-life environment, it's very important to generate real-like traffic, not just using call, command, and simple request. You need to use the real web browser so that it make a real-like traffic. Not just web browser, for all the protocol level access, we need to mimic so that it looks like a real ones. And the visualization, as I showed you before, I found that the observer, if you are a blue teamer or red teamer or green teamer, we know what is happening in the CDX because you are in the network. But we have observers asking, can you show me what is happening? So I thought that this availability check is one good thing to show them. Okay, one of the red team's campaign is degrading blue team's service, and we can visualize them, easy to read for the observers, so that they understand what's going on in this CDX. And also, it is very important to make checks well, availability checks well. If you don't write well, then blue teams will perform so-called evasive tactics. They are interested in get scores rather than focusing on training content itself. That is different from real life. In the real life, maybe usability is more important for the IT systems. But in CDX, because blue teams are very assiduous in defending performance, they wanted to set up that has very excessive security. That could be different from reality. And if it is different from reality, it affects to the training effect. We are doing this exercise for like to be ready for the attack in the real life. We wanted to make the situation same like that is in real life. So it is very important to make real world-like usability check and availability check. And this is the first GAMENET of the Apex. It was last year. We had 3 subnets on the right side with the blue background. And this is the second GAMENET that we had just a month ago. We had the second iteration of Apex. We had last year we had 3 subnets. This year we had the 7 subnets with 3 OT domains. Then I want to continue with the cost management. I told you already, the fund allocated to us was not. It was limited, so we need to find a way to reduce cost of using Azure Cloud. At the first, we thought about using reserved instances. We can make a contract saying that, okay, we are going to use these VMs for 2 years or 3 years. Then they will give you, for example, 40% account by maximum. We did this and asking that, can we cancel this contract? They said, yeah, 1 or 2 times is okay. But if you are abusing this cancellation, then you might cannot use this Azure Cloud anymore, because anyways, it's kind of contract. Reserved instance is kind of contract. So it was not, I think it was not suitable for in our case, because we are deploying our systems for 2 teams only in the developing phase. 51 for the granting purpose and 52 for the rating purpose. And when it's time for the Python's run or main execution, we are scaling up to the all teams. So reserved instance does not help for our situation. And we found the other way using inventory. As I told you, I made an inventory that has all the VM information there. If there's a VM does not listed in this inventory, but is in the Azure resource, we show the users like this with the red text. There's an orphan VM, so if there's an owner of this user orphan VM, please list it, add it in the inventory so that we know your VM is there. Otherwise, we are going to erase it. We wanted to know all the VMs in the inventory. We wanted to make sure like that. And in this inventory, there's information about the CPU and RAM disk. Then we can do some calculation, expected cost of using all the VMwares. And finally, we made a service, an additional service, so-called VM clone, that turns off these VMs in the night every day. For every VM, it turns off. And in the morning, it turns on. Because we are using cloud environment, the cost is calculated based on we used. So by using VM clone, turn on in the morning, turn off in the night, by using this, we could use huge amount of money. And we could set this schedule respectively for all the different VMs. For example, the DNS and the routers, they need to be turned on 24/7 so that other VMs can communicate, make a communication. So we can do setup like that in the VM clone service. So we made the GAMENET. Throughout this presentation, I showed you what services we made for making exercise platform. So, and it was possible to make like a small size of live fire exercise. But if you are saying that you have GAMENET, you have the exercise platform, there could be a demand that, okay, maybe we can doubling up the size live to make a large scale and the full scale. Actually, large scale means it means additional service. Full scale means we want to add the non-technical content as well. For example, media, law, and the strategic level, decision-making process level we want to test. We want to do some exercise in this GAMENET. Then what is important for further exercise is that we need a sustainable, stable core team so that they can enable this live fire exercise. And it is very important to make a strong community because it's highly likely core team member is small number. But live fire requires many services. Then we need many number of external experts so that they can volunteer their knowledge. For example, they want to make OT system, any services in this GAMENET. So this is the core green team technical knowledges. I can just simply, as is time. So thank you for your attention. So if you have questions, feel free to ask me. Thank you.
All right, thank you. Let's take a question if there's any from the audience before I shift to my questions. Okay, I will warm up with the questions from my side. So please do tell me how many VMs in total a single GAMENET would approximately hold if you have this number in your head.
You mean the number of VMs?
Yeah.
I think in the Green Team network, I think around 200.
Say again?
In the Green Team network, we had around 200 VMs.
Also, it's blue team machines as well, right?
In the blue team, for each blue team, we had like 30, 35.
30, 35.
Yeah.
And how many blue teams were there in the end together? Because I don't think I saw this mentioned, but maybe you can mention.
You mean blue teamers?
Yes. How many blue teams in total there were? Because you just scaled.
There were 8 blue teams.
8 blue teams. So just everything multiplied by 8 in the end. So any particular reason why you chose Azure? Is that because you already had an existing contract, or because it's easier, or you knew how to deploy stuff there?
Actually, at the beginning, this was my first time of using Azure, so I had no knowledge before we chose this Azure. It's simply because at that moment, we didn't have on-premise server ready for this exercise. So choosing cloud environment was the only option.
All right, and live fire means that you also have an opposing red team, right?
Yeah.
So how did you integrate the red team? Were they connecting to the consoles? Were they SSHing into this? How many red teamers were there? How did you spread them across the GAMENET as well?
We had around 10 number of red teamers, and they, similar to Luxus, they had their own targets, but because Luxus has many teams, but in Apex we had only 8 number of teams, so they could handle the 8 teams to attack for their targets.
And when you mentioned about the simulating the traffic or generating the traffic, so what did you exactly use? Did you use some pre-made scripts that would just run the particular service or mimic a user behavior, or did you use traffic generators for that?
I didn't bought any traffic generator. I made a script by myself. For example, I used for example, nowadays I'm using the cursor, this IDE for developing things, and I connected to this cursor with the browser MCP. And using vibe coding is famous nowadays. I asked the AI to, okay, visit this web service and get to know URLs you need to visit. And if there's HTML forms, you need to test it. In that way, I made a script to mimic the user behavior. Yeah.
All right. Well, thank you so much. Let's give a round of applause again for Youngjae.
Thank you.